Here we have part 2 lecture for inflation, and we're talking about the CPI on how we calculate that. And these are the actual numbers that I got from the Bureau of Labor Statistics. And going back to 69, this is the index here, 36.7. And this again is based on the base year being the average of 82, 83, 84. And so these tell us right real fast that prices were a lot lower than the base year back in the 70s. And then over here in 2006, you can see it's 201.6, a lot higher. And then we have these numbers here, 2007 to 2019. Notice that they added some decimal points here. I guess they think the data is more precise now. That's good. Now over here I have the inflation rate, and this tells us the percent change in the CPI. So on the exams, you will be asked to determine the inflation rate based on some CPI numbers that I give you. And the inflation rate simply is the percent change in the CPI. So you can look at it as being the CPI in the current year minus the CPI for the previous year and divide by the CPI for the previous year. You always want to divide by where you came from because you want to see the change based on where you came from. And that would give you a decimal, and then you times by 100 to change the decimal into a percent. Some people like to look at it maybe as year 2 and year 1, if that works for you. Year 2 is the year you're going toward. That's the year. Year 1 is year, and divide year 1, and that gives you the decimal change, and then you times by 100 to get the percent change. So right here, a question on the exam would be CPI for 2018 is 251.107. And for 2019, it's 257.476. And the question is, what is the inflation rate between those 2 years? So year 2, the current year is, in this case, 2019. So you would take 257.476. Subtract from that the CPI from the previous year, which is 251.107. Divide that by the CPI for the previous year, again as year 1, 2018, 251.107, and then you times 100 to get the percent. So get my calculator out. And so we have 257.476 minus 2, of course I'm going to make a mistake, 257.476 minus 251.107, that gives us, again, a mistake, 257.476 minus 251.107, and that's 6.369. You divide that by 251.107, and that gives us 0.025. And then you times by 100, and that gives us 2.54%. Now on the exam, if I don't tell you where to round it to, you can always round it to the nearest whole number. In this case, if I say round this to the second decimal, which is probably what I would do, that would be the second decimal. That's the first decimal, that's the second decimal, and so if I say round to the second decimal, you round it to 2.54. Even if the number, say, is 2.00, you still want to give me 2.00 to the second decimal. If you say 2% on the test, and the answer is actually 2.00, that would be wrong, because they're not the same number. This number is much more precise than that number. This gives us more information than that number does. So if your boss says round to the second decimal, I don't care if it's 000, you give them the zeros there, because again, that tells me a lot more information than that number there. So in this case, it's 2.54%. Find the inflation rate from, say, the base year to 2019. Do the same thing. Now we're going from the base year to 2019. 2019 still is a current year. I didn't give you the CPI for the base year on this question, but we know it's 100. And you can just add 300 if you want to, make it look pretty. And then we divide by times 100. Now if you notice, those cancel, and so we don't need a calculator, just take that minus 100. And so this will give us 257 0.476 minus 100, and so that gives us 157.476%. So that's also a nice reason why the base year is 100. We don't need a calculator to find the inflation rate from the base year to any other year. Simply take whatever the current base year number is. Take whatever the current CPI number is. Minus 100 from that. Subtract 100 from that, and that'll give you the answer right there. So it makes sense. You go from 100 to 257. That's more than doubled, and that's why it's over 100%. Go back to the little data. You can see that here in the 1980s and 90s, or 88, 89, 2000, we've had pretty good numbers. Go to the 70s, and you can see really high numbers. This is what we call double-digit inflation, when inflation was, say, 11%, 10%, 13%, really high numbers. And so we'll talk more about that in this chapter and also further on, because this was a very unusual period in the 70s, which has greatly affected the operations of the Federal Reserve. We never experienced this high inflation before or since, and therefore this has been something that's been studied quite a bit, and it's something that the Federal Reserve wants to avoid as much as possible. And then go closer to our time. You can see the numbers are pretty good. So lately they're about 2.1, 2.4, 2.5, all pretty good numbers. Notice we have a negative number there. That's deflation. And I think that's the only negative number on all these charts. Yep. Even though we had recessions in the years here, the only recession that really had deflation was the worst one of all the recessions until COVID, of course. And again, prices from 08 to 09 went down by 4%. You see the CPI in 09 a little bit lower than the CPI in 08. So that's deflation. That's when the CPI is falling. That's when the inflation rate is negative. We also have a term that's called disinflation, and that is when the CPI is still rising, but the increase is slowing down. And so disinflation is when the rate of inflation goes down. So here we can see going from 5.4% in 1990 to 4.2% in 91 to 3% in 1992. That would be disinflation right there. Prices are still rising, but they're going up by a slower rate for those 3 years. Another term to know is the core CPI. Focus there. There we go. Core CPI came across, or was actually used the first time in the 1970s when we had that high inflation. We were trying to strip away some areas that are volatile. They change a lot, and that tends to be energy and food prices. Maybe personally you've seen that over your own lifetime, seeing the price of gasoline going up and down quite a bit, food prices gyrating quite a bit. And so maybe and energy and food prices are due to disruptions in supply chains around the world, due to actions by, say, cartels like OPEC, and it could be weather patterns. So a lot of things can really influence energy and food prices quite a bit. So if they spike, go up a lot, it doesn't really mean we have inflation really ingrained in the system. It could be just a fluke for that time period. And so we came up with the core CPI to maybe see if we can get a better idea of what's going on with inflation if we strip out the more volatile areas. And so the core CPI is the same CPI as we use, as I showed you with the market basket, except energy and food prices are taken out. And so it might be a better tool to recognize the underlying trends, whereas the CPI itself is more likely to give us a skewed view of inflation, because it might be affected by, again, weather problems with weather, problems with maybe strikes, hurricanes, things like that. Which one's a better one? Look at both. I tend to agree, or I tend to believe that more data is better than less data, and so you look at the core CPI, look at the regular CPI, and use the data as best you can. The next topic is going to be nominal and real. We talked about nominal GDP and real GDP, and now we can talk about nominal value and real value for anything. It's not just GDP, but anything. So nominal value of any item, it could be the nominal value of your salary, the nominal value of a price of a dishwasher, the nominal value of a price of a home. At any time is the value expressed at that time in dollars. So if you paid, say, $600 for a dishwasher in, say, 2018, that is the nominal value of that dishwasher. If you earned $10,000 as a part-time job in, say, 2014, that was your nominal pay in 2014. The problem with the nominal value is that, again, you can't compare it over time. Say you paid, say, $700 for a dishwasher later on, say in 2020, this year. Does that mean you paid more? I don't know. Because again, the dollars that you had back in 2018 had a higher value. They could buy more than the dollars in 2020 because we've had inflation since 18 to 2020. So I don't know if you actually paid more. You could actually pay less in real terms. And so again, comparing nominal values from one year to another is not a fair comparison. The real value is what you want to look at. So the real value of any item is expressed in dollars that have constant purchasing power. So if you have dollars with constant purchasing power, you've taken inflation out of the system. And so real value comparisons are meaningful, nominal value comparisons are not. And the next step is to go through some examples of converting nominal values to real values, and that'll be the topic of next lecture, part 3.